So, let's have a look at an example related to the experiment we have been talking about. How can we solve numerical problem based on that very experiment we have described? Now, the question is, an object O is placed 40 centimeters in front of a convex lens of focal length 15 centimeters, forming an image on the screen. A convex mirror situated 4 centimeters from the lens in the region between the lens and the screen forms the final image besides the object O. Then they are saying out of that, draw a ray diagram to show how the final image is formed. And then to determine the focal length of the convex mirror. So, what do we do in this case here? We can now draw our ray diagram. Our ray diagram, I can do something like that. They are saying that an object O is placed 40 centimeters in front of a convex lens. Number one is to first draw our convex lens that I would say this is our convex lens, and now they are saying that object is here. Okay? Our object is there, and it is located 40 centimeters. This is object O, but the distance from here up to here is 40 centimeters. Okay? And they are saying that object O in front 40 centimeters from the lens. So, and then they say that the focal length of the lens is 15. That means that F here of this lens is 15 centimeters, the focal length. And then they're saying that it forms an image on the screen. The image basically will come this other side here. Supposing the image is formed here as I, our screen is here. What is the ray diagram? That means a light rays will come from here and then will come here, okay? And then it means that it is supposed to come this other side here, okay? It is supposed to converge up to this point here. In absence of the lens, before introducing the mirror, this image here, you were supposed to draw a full line, not dotted here. Okay? It was supposed to be a full line, but I'm dotting it because in the following instruction, you will realize that they're saying a mirror was introduced. And if a mirror is introduced here, this image becomes virtual. It is no longer going to be here. Instead, it is going to go the other side. That is why I've dotted it as per now. But in absence, if the drawing was supposed to stop there or following the instruction up to this point before introducing the mirror here, I would do it as a full line, okay? But I'm dotting it because I know in the following instruction, we are going to introduce a mirror and the image will go back the other side. So, they are saying that it forms an image on the what? On the screen. So if this is the image which is formed on the screen, they are saying that a convex mirror situated 4 centimeters from the lens in the region between the lens and the screen. The screen is where the image is and the lens is here. So there is a convex mirror here. Is that okay? There is a convex mirror that is introduced, and they are saying it is 4 centimeters. It is 4 centimeters from this mirror here. From the distance from the lens up to the mirror is 4 centimeters. From the screen and the region between the lens and the screen, forming a final image beside the object O. That after introducing this mirror here, what happens is the light which was coming forming image here is now going to be, if it comes, it is no longer coming this side, it is going to be reflected from here. But if it is reflected, it will follow the same path, because they are saying the object and the image, they are all going to be now at this point. So for that to happen, it means that the incident ray is reflected along with the same path to make the image and the object to be at the same point. And we are aware that if the reflected ray is normal, or if the image and the object, they are all at the same point, what is very true is that the reflected ray is going to be normal or is going to move along on the same path. And we said that if that has happened, if this has been normal here, and you happen to continue with this light, the point where it will cut this principal axis will be our center of curvature. And now this distance here qualifies to be our radius of curvature. Is that okay? We looked at it yesterday that if an object and the image are all at the same point, it means that the image is incident normally and reflected also normally. And that was this drawing here, if you can still remember. That if I have my lens like this, if this is the pin above it, if it so happens that the image of this all at the same point, it means that the light rays coming from the object is perpendicular here. That's why it is coming along with the same path to form the image at this point. And then we put this arrow to show that the incident ray and the reflected are all along with the same point. And we said if light rays are normal here, the point where the two meets is our center of curvature. And if we have that as center of curvature, the distance from the pole to the center of curvature is given a name of R. We looked at it. So the same thing here, that if the light rays comes and follow the same path to take the image at the same point, an object that is equal to, that one is what we are calling the radius of curvature. So, and now basically, this is what we are calling the ray diagram for showing the formation of the final image. So, now they are telling you to determine the focal length of the convex lens. To determine the focal length, now this is Roman 1, and now this is my Roman 2. I can now say action of the, considering the action of the lens, okay? And then if we are looking at the lens, the focal length of the lens is 15 centimeter. The image, the object is located 40 centimeters from the lens. And where is the image going to be? In absence of this, if this lens picks this object here, where is it going to put the image? So we shall say, using this formula here, it also applies to lenses, as we shall look at it in our upcoming sessions or subunit in light. So we shall say, if we are using this for lens, I'll say 1 out of 15 is equivalent to 1 out of 40 plus 1 out of V. I can say here, I can subtract the other side. Let me move slowly. 1 out of 15 minus 1 out of 40 equal to 1 out of V. What is my LCM? You can look for the LCM, which should be, let me see, 30, 60, it will be 120, eh? Should be 120. LCM is it? 120. So what is 120? Divide by 15 there, it will be like 8, eh? What is 120 divided by 15? That is 8. So you write here 8 minus 120 divided by 40. That will be around what? 3, equaling to 1 out of V. That is 5 out of 120 equaling to 1 out of V. And V equaling to 120 divided by 5. What is now 120 divided by 5? That is 24. That V equaling to 24 centimeter. What does that mean to us? That this lens here, in the absence of this mirror, the image that it is going to pick here was going to be formed at a distance. This image here is going to be at 24. When you measure it from here, that if you remove this mirror, here and place an object at 40 centimeters from this lens, it will form it at a distance of 24 from it on this other side. Okay? So that means from here up to here is supposed to be 24. And now, what next? We are also going to say that if this is C, this is my P, this is my L. I will now say also, we said this is going to act as our radius of curvature, because if this is perpendicular and extend this line here, this distance is the radius of curvature. Therefore, your R will be equivalent to 24 from here up to here minus 4. And your R is equivalent to 20. Okay? This R here is the radius of curvature, because if this line strikes here perpendicularly, we said if you extend that line and it cuts here, this will be center of curvature. And if this center of curvature, the distance from the pole to the center of curvature is the radius of curvature. So meaning our radius of curvature will be 20 minus this separation 4. And you know focal length is radius divided by 2. My focal length will be 20 divided by 2, and that is 10. And we say our focal length is negative. You can say it is negative 10, isn't it? Actually, you can substitute it right away from here. I can say R equaling to negative that, because I know the radius of curvature is supposed to be negative for convex. So this will give you negative 20. So you say negative 20 divided by 2, that is negative 10 centimeter. But when we are concluding, you say, therefore, the focal length is 10 centimeters, isn't it? Only that we know that the focal length for convex mirror is supposed to be a negative value. Okay? So when we are working and say negative this, because it's supposed to be negative, but in making conclusion, just call it a positive. So let's meet in the next episode.